See, today we are going to discuss about the stress. In previous lecture, I have told that when we are applying the deforming force, there will be change of shape and size. When deforming force is removed due to internal restoring force, it regains its original configuration or original shape and size. So this restoring force, internal restoring force, when deforming force we have applied, so this internal restoring force per unit area, that is called stress. So what is stress? Stress mean the internal restoring force acting per unit area of cross section of deformed body is called stress. So stress is internal restoring force per unit cross section area, that is called stress. So stress is restoring force upon area of cross section. See, force upon area, so what will be the unit of this? The unit of stress, we can say unit of stress is Newton per meter square, that is Newton per meter square. Also you can say Pascal. Okay, same unit of pressure. One thing more, this stress is not a vector quantity. Stress is not vector quantity because we cannot give at a specified direction. हम कोई specified direction नहीं दे सकते. तो that's why what this stress is not a vector quantity. Vector quantity नहीं. This we can treat as a scalar quantity. First thing. Second thing, at equilibrium, so stress is equal to, at equilibrium, what we will say? Equilibrium. At equilibrium, the external force what we have applied, or deforming force we have applied, that is equal to what? Restoring force. But remember, at equilibrium, restoring force is equal to external applied force. External force. So remember, this restoring force is equal to, at equilibrium, that is equal to external force, or that time you can say deforming force. But remember one thing, that stress is not equal to deforming force per unit area. Sometimes what happen, we are applying deforming force, but there is no internal force or restoring force. That is also called plasticity. So deforming force we have applied, but there is change in shape and size, permanently change in shape, or there are partially change in shape and size. So internal force is restoring force per unit area is stress, not deforming force per unit area. At equilibrium, deforming force is equal to restoring force. That time we can say that stress is equal to deforming force, but at equilibrium. Okay, so remember one thing, it is not necessary that restoring force is equal to deforming force. Maybe restoring force is less than deforming force. Maybe there is negligible restoring force when deforming force we have applied much more. Okay, and that we also know. Okay, where restoring force is less, so that time object will show plasticity. Okay, plastic property. So elastic property it will show when there is a large number of internal restoring force. So remember that stress is deforming force will not develop the stress. Deforming force will develop the strain. Okay, and stress is developed due to internal restoring force. So remember these things, and its unit is Newton per meter square, and stress is not a vector quantity. At equilibrium, restoring force is equal to external force. See, this stress can be divided into three parts. First, we can say as a longitudinal stress, and there is a longitudinal strain, or change in length. So that is called longitudinal stress. Second, we can divide it as a volumetric stress when there is change in volume due to stress. So that is called volumetric stress. Also it is called hydraulic stress. And third, when shearing strain is there, shearing stress. So there are three type of stresses there. One is what? Longitudinal stress. Second, we can say as volumetric stress. Third, we can say as a shearing stress. So see here, what is longitudinal stress? Longitudinal stress mean restoring force या stress produced when a deforming force acting on along the length of body or a rod. Longitudinal stress. When stress is such that when deforming force acting along the length of body and deforming force changes the length of object or length of body or length of rod. So that type of stress or internal restoring force per unit area, that is called longitudinal stress. So longitudinal stress is restoring force perpendicular to cross section area when length is increased or decreased. So restoring force that time per unit area is known as per unit cross section is known as longitudinal stress. So remember, longitudinal stress comes when stress due to change in length of body by deforming force. So that is called longitudinal stress. It also we can divide in two parts: tensile stress and compressive stress. When there is change in length increases due to force, length increases like that. So that is tensile stress. When you have applied a force and length decreases, this is the rod and you have applied force and length decreases, so that is called compressive stress. In tensile stress, what happen? We have applied deforming force, intermolecular distance increases. What happen? I have told you earlier, like that graph. When there is change in length, what happen? Internal attraction force increases. Interatomic attraction force increases. That's why stress or inter restoring force per unit area due to attraction. So that is tensile stress. When compressive force we have applied, the distance between molecules, atoms decreases. That time what happens? Repulsion force increases. So due to that repulsion force, the internal restoring force per unit area at that time, so that is called compressive stress. So longitudinal stress also can be divided into two parts: tensile stress and compressive stress. Tensile stress when length increase, and compressive stress when we have applied force such that length is decreases. Tensile stress, interatomic attraction force increases, due to that stress produced. And compressive stress, the interatomic distance decreases, that's why repulsion force increases, and due to that compressive stress produced. So see here, what is volumetric stress? We have discussed longitudinal stress. So volumetric stress mean, and it is also called hydraulic stress, when a deforming force acting on a body produces change in its volume. Longitudinal stress, what we have seen, change in length. Here change in volume. So the stress is called volumetric stress. So see, suppose I have symmetrical, compressive and normal forces applied on a surface area of a body. Suppose one sphere I have taken, a spherical ball, suppose I have taken, and I have applied compressive force upon the area, symmetrical, and from all sides I have applied same force. and there is change in volume. Sphere, its volume reduced. Suppose initial its volume is V, and after compression its volume becomes V dash. Okay. For example, if a sphere you have taken and you have come inside the deep water where pressure will increase from the surface. Okay. So from all sides, symmetrical compression normal forces will act, which will change the volume. It will act on this force will act on the surface area. Symmetrical force from all sides. So this force per unit area is known as volumetric stress. What is volumetric stress? Volumetric stress is a stress which changes the volume of object. This is sphere. This is sphere I have taken, and upon the surface a symmetrical force, normal force F is acting. The volumetric stress is equal to this applied force per unit surface area. Sometimes it is also called as pressure. That is volumetric stress. Volumetric stress, when a deforming force acting on a body change its volume, this stress is known as volumetric stress. See, shearing stress. Shear stress, whenever there is a relative displacement of a successive layers of a body, the restoring force is set up parallel to the surface, that is called shear stress. Actually, shear stress, a different type of stress, when there is a change of shape, change of size, change of shape. Okay. So the shear strain actually may measure of a position offered by body due to change in shape. For example, suppose one cube I have taken, and this surface I have fixed, lower surface I have fixed, and a tangential force to this surface I have applied. What happened? So change in shape. It will go here like that. There is change in shape. So this change in shape upward, you can see it, change in shape upward by the body. It will go here, and suppose it will go here, this surface. So you can see here change in shape. So this change in shape, there is a lateral displacement, this delta L, lateral displacement. So this force per unit area, this area, here force I have applied. I have applied force at this point. So this force per unit area, this is called tangential force, tangential to the surface. This force per unit area is known as shear stress. And after that also we will tell this displacement per unit length, that angle theta is called shear strain. So when there is change in shape, what change in shape takes place? And this perpendicular line, this will compress, and external side will stretch. So change in shape, when there is change in shape and one opposing force will develop due to change in shape, so that opposing force which is parallel to the surface due to successive change in layer, so that stress is called shear stress. And due to shear stress you will see there will be shearing strain. So shear stress is the stress which is developed due to change in shape of body, so that is called shear stress. And here shear stress is equal to restoring force parallel to the surface upon area of surface, or tangential force F, suppose I have applied here for the change of shape, and the area of this is F upon A is known as shear stress. Shear strain. What is strain? When a deforming force we have applied, there is change in dimension. So the ratio of change in dimension to original dimension, that is called strain. So strain is defined as the ratio of change in dimension of body to its original dimension. That is called strain. So strain is change in dimension upon original dimension. One thing noted here, it is ratio of two similar physical quantity. That's why it is dimensionless. Mean strain has no units. See, in elasticity, what happens when deforming force is applied? They cannot accelerate, body cannot accelerate, so there will be 100%, there will be change in shape or size. So change in dimensions upon original dimension, so that is called strain. So it is three types. One is what? Longitudinal strain. See here, when stress, I wish we have told you three type of stress is there: longitudinal stress, volumetric stress, shearing stress. Like that, there are three strain is there. When longitudinal stress applied, so longitudinal strain is there. When volumetric stress is applied, there is change in volume, so volumetric strain is there. And when shearing stress is applied, shearing strain is there. So three type of strain is there. First is longitudinal strain. When longitudinal force, when a force along the length of wire we have applied, maybe tensile, maybe compressive, that time what is change in length upon original length? There is a change in length upon original length, that is called longitudinal strain. Longitudinal strain is what? The strain produced by a tensile or compressive deforming force along length is called longitudinal strain. Suppose one wire is here, I have applied a force, there is change in length del L, original length is L, so del L upon L, that will be the longitudinal strain. So longitudinal strain is the ratio of change in length to original length, or you can say longitudinal strain is measure of relative change in length of body, that is called longitudinal strain. Next one is what? Volumetric strain. What is volumetric strain? A deforming force acting perpendicular to entire surface of a body produces volumetric strain. First longitudinal strain, second one is volumetric strain. When a deforming force are such that it acts uniformly all over surface of the body, what happens? There is change in volume. So the relative change in volume of body is known as volumetric strain. Volumetric strain is measure of relative change in volume of body. Mean, suppose this is a sphere. If all surface F force is applied from all sides, what happen? There is change in volume. If change in volume takes place, change in volume, suppose initial volume is V, further volume becomes V minus del V. So change in volume is del V. So del V upon V, the relative change in volume is known as volumetric strain. What is volumetric strain? It is defined as the ratio of change in volume to original volume. When a deforming force acting perpendicular to entire surface, that is called volumetric strain. Next one is what? Shearing strain. So three type of strain is there: longitudinal strain, volumetric strain, and third one is shearing strain. Same thing we can apply it for cube also. Suppose I have taken one cube and we have applied forces from all sides. The change in volume of cube, change in volume of cube, forces is applied. So change in volume of cube. So that is also known as change in volume one, original volume, volumetric strain. So we have to know about the volumetric strain. Shearing strain. when a tangential force is applied. This cube I have taken, this is fixed surface, upper surface can move. When a tangential force we have applied between these two surfaces, what happen? This upper surface will display. Suppose this has displaced del L distance. So what is shearing stress? Shearing strain. When tangential force is applied, there is a relative displacement del L of top face with respect to bottom face. The relative displacement of two surfaces. This relative displacement of two surfaces per unit distance between the surfaces. Suppose this is upper surface, this is lower surface, the distance between upper surface and lower surface is L. So per unit this length, the relative displacement of upper surface per unit this distance between two surfaces, upper and lower, so that is called shearing strain. So what is shearing strain? Displacement of upper surface divided by distance between the two surfaces. So shearing strain is strain which is due to change in shape. When there is a change in shape, that time what strain developed inside the body, that is called shearing strain. And how it is defined? The shearing strain is defined as the relative displacement of upper surface with respect to fixed surface per unit distance between the two surfaces, that is called shearing strain. So shearing strain, suppose I have applied tangential force F, so there is a displacement del L. You can see here upper surface with respect to fixed surface or lower surface displacement is del L, and distance between the two surfaces is L. So del L upon L, see here del L upon L, this can be also as written as tan theta. See, del L is very small comparison to L. So del L is small, so tan theta is nearly equal to theta. That we can say angular displacement of surface perpendicular to applied force. So shearing stress is also defined as the angular displacement of surfaces perpendicular to applied force. So shearing strain is related with the change of shape. When change of shape takes place, so that time angular displacement of surface perpendicular to tangential force, or you can say applied force, that is called shearing strain.